We are in our quadratic lesson. This is lesson 5, building quadratic functions to describe situations, or basically creating word problems or a math model for real world situations. So first of all, we're going to study this table, and we're going to go with what do we notice and what do we wonder. So first of all, from the table, I notice that our rate of change or change in y is not the same. So we start adding 15, and then here we go from 16 to 64, and we have a different rate of change. So what I'm going to do is just notice that. So that's a noticing. The rate of change grows. So we can conclude from that this is not linear. And I'm going to examine that rate of change a little bit more. So I'm going to look here and notice here's an actual problem. A rock is dropped from the top floor of a 500-foot building, and a camera captures how the rock travels in feet. So I'm just going to put that information in our table vertically. So our x value is going to be the time, and our y value is going to be our distance. And at time 0, our distance is 0. At time 1, our distance is 16. At time 2, our distance is 64. At time 3, our distance is 144. At 4, we're at 256. At 5, we're at 400. And we're going to have to get time 6, so I'm going to put it down there. Now, as I examine my rate of change, to go from 0 to 16, we go up 16. And then here, if I do 64, minus 16, we can see that I increased by 48. And then 144 minus 64, I went up by 80. And then 256 minus 144, I went up by 112. And then here, 400 minus 256 is 144. Now I notice that change of y is increasing. What we call this pattern right here, though, is our first difference. And what I'm going to examine is see about my second difference. So how is the change in y of change in y? And it's a little sloppy there and I can't fit it in, but that's okay. So here I go 48 minus 16 and I get 32. And then I'm going to take 80 and minus 48 and I get 32. Looks like my second difference, or the change in y of the change in y, is always going to be 32. So if I want to figure out, well, from 5 to 6 seconds, how much am I going up by? I know I'm going to take 144 and add 32. So adding 32 to 144, I know that I'm going to have 176, which means from 5 to 6 seconds, I'm going to go from 400 plus 176, which is going to give me 576 feet. Which in this case, the building's only 500, so I can conclude this is actually going to go and it wouldn't fit in the model because at the ground, the rock would stop. So how far would the rock fall after 6 seconds? It would be 576 feet, which we already said doesn't make sense because the building is only 500 feet. Now we said, Jada wrote down that 16 equals 16 times 1. 64 is 16 times 4. 144 is 16 times 9. And these are all multiples of 16. She also noticed that 1 is 1 squared, and 4 is 2 squared, and 9 is 3 squared. So really, this is 16 times 1 squared. And here we have 16 times 2 squared, and 16 times 3 squared, and 16 times 4 squared, and 16 times 5 squared. So if you notice, this is for step 1, and then here, this is step 2. So step 1 is 16 times 1 squared. Step 2 is 16 times 2 squared. And then here, I'm going to skip a few, and we have step 5 is 16 times 5 squared. So to answer question A, what's the distance going to be after 7 seconds? It looks like I'm going to say 16 times 7 squared. And reading this, it says, assume that the building is tall enough, so we must have moved to a different building. But I'm going to use my calculator to put that in. So 16 times 7 squared. And I notice I get 784 feet. And then to write an equation, well, it looks like if I did t seconds, so d is distance in feet, and t is time in seconds. So d equals 16 times t squared, or just 16t squared. So for 5.3, Galileo noticed that you can express this as 16 times t squared. So if I had 0.5 seconds, how far does this object fall? We would say d equals 16 times 0.5 squared. And using the calculator, 16 times 0.5 squared gives us 4. So to answer that, I should make sure I include a unit. This is going to be 4 feet. In filling in the table here also, we can go and it's going to be those. For this one, it's 16 times t squared. So 16 times 1 is 16. 16 times 2 is 64. 16 times 3 squared is 144. And if you notice, we're just filling in the numbers here. So this is going to be 256 and